Objective: to understand the first scientific atomic theory. The first scientific theory about atom was put forward by an English chemist, John Dalton, in 1803. He described an atom as a solid hard sphere which is neutral with no charge on it. Let's understand the postulates given by him in his atomic theory. Composition of matter. Consider an element, for example gold. See what it's made of? As you can see, it is made of particles of the same type. Whereas a compound like water is made of particles of two different types. A closer look at the mixture of iron and sulfur enables us to see that it is made of very tiny particles of iron and sulfur. Dalton called these tiny particles that matter is made of as atoms. All forms of matter, whether an element, a compound, or a mixture, is made up of very tiny particles called atoms. Indivisibility of atoms. Consider a piece of the metal gold. When you try breaking a piece of the metal, gold, into smaller pieces, at some point it becomes impossible to break it any further. Dalton called this smallest particle of matter an atom, and he further stated that the atom is indivisible. Atoms of similar elements. Consider a pure gold coin and silver coin. Pure gold coin is made up of gold atoms only. Similarly, in silver coin, there are no atoms other than silver atoms. If you observe the atoms of gold closely, they look identical. They seem to have the same shape, size, and mass. Therefore, it can be said that atoms of the same element are alike in shape, size, mass, etc. Now let's observe how different atoms of gold react with atoms of another element, say chlorine. The atoms of gold react with the atoms of chlorine, and they all form the same compound, auric chloride. So, Dalton, in his theory, proposed that not only are atoms of an element identical in size, shape, and mass, they also possess the same chemical properties. Atoms of dissimilar elements. Let's now compare the atoms of hydrogen and oxygen. As you can see, the oxygen atom is bigger than the hydrogen atom. Also, the mass of the oxygen atom is greater than that of the hydrogen atom. If both hydrogen and oxygen are allowed to react with sulfur, you may observe that hydrogen reacts with sulfur to form hydrogen sulfide, while oxygen reacts with sulfur to form sulfur dioxide, which are two different compounds. Therefore, Dalton proposed that atoms of different elements are different in all respects. Role of atoms in a chemical reaction. When two elements such as magnesium and chlorine react, the product formed is magnesium chloride. Can you see any new atoms formed in the product other than magnesium and chlorine? No. Even though there is a change in the arrangement of the atoms in the product, magnesium chloride, it is made up of the atoms of the reactants, magnesium and chlorine, and no other. So, Dalton suggested that, in a chemical reaction, atoms of an element get rearranged but do not change into atoms of another element. The atom is also considered as the smallest particle that takes part in the chemical reaction. Invincibility of atoms. Let's now consider a few reactions. Hydrogen reacts with oxygen to form water or steam. Let us try to find the number of atoms of reactants involved in the reaction, and also those in the product formed as a result of the reaction. On studying the chemical equation closely, we see that there are 4 atoms of hydrogen and 2 atoms of oxygen on the reactant side. And on the product side, we have the same number of atoms, that is, 4 atoms of hydrogen and 2 atoms of oxygen. Let's study another chemical reaction to understand this better. Zinc reacts with dilute hydrochloric acid to form zinc chloride and hydrogen. In this reaction too, you may observe that both the reactant side and the product side contain the same number of atoms. That is, 1 atom of zinc, 2 atoms each of chlorine and hydrogen, making it a total of 5 atoms on both sides of the equation. This endorsed Dalton's finding that atoms are neither created nor destroyed in a chemical reaction. Combination of atoms. Let's observe the formation of a compound from atoms. Here, hydrogen atoms combined with oxygen atoms to form water molecules. That each water molecule has 2 atoms of hydrogen and 1 atom of oxygen. The ratio of combination of hydrogen and oxygen to form water molecule, H2O, is 2:1. Similarly, 1 atom of carbon combines with 4 atoms of hydrogen to form 1 molecule of methane. Here, the ratio in which carbon and hydrogen atoms combine to form methane is 1:4. So, Dalton concluded that atoms of different elements combine in fixed proportions or in a whole number ratio to form compounds. Let's now summarize the points of Dalton's atomic theory. All forms of matter, whether an element, a compound or a mixture, is made up of very tiny particles called atoms. The smallest particle of matter, called atom, and is further indivisible. Atoms of an element are identical in size, shape and mass. They also have the same chemical properties. Atoms of different elements are different in all respects. In a chemical reaction, atoms of an element may get rearranged, but they do not change into atoms of another element. The atom is also considered the smallest particle that takes part in a chemical reaction. Atoms are neither created nor destroyed in a chemical reaction. Atoms of different elements combine in fixed proportions or in a whole number ratio to form compounds.